Hello everyone. My name is Mukund and I didn't work with a partner, but I created an AI powered FPL optimization platform. So now let's talk about the project goals. My idea was to help FPL players get data driven recommendations so that they can optimize their own team to maximize points for each game week. The application enables the user to either obtain the best team for the upcoming game week, or the user could enter his own team into the app and use it to obtain an optimal transfer for that week. Now let's talk about the software components. So we've used Docker and Kubernetes to containerize our applications and deploy them. React for the front end, Flask for the back end, Postgres to store player data and expected points for all the game weeks. Redis as a key value store to enable caching cache frequently access data such as optimal team of the week. As for the hardware components, we've used Google Kubernetes cluster with nodes of type N1 standard 2, Postgres database with 10 GB as memory, and Redis cache with a maximum memory of 256 MB. So now let's take a look at the architectural diagram. Users will interact through the front end. Front end is deployed with a load balancer on multiple pods. The UI interacts with the other components through the backend service, which runs on separate pods. Backend interacts with the other services based on the query it has received from the front end. Um, so if the user has requested the optimal team for the coming game week, then the Flask app checks if it's present. If the data is cached in Redis, if it is not, then it calls Postgres to obtain and then processes the data to formulate the best possible team. After this, the Flask app stores this into Redis and also communicates it to the front end. Now, if the user has entered his own team and wants an optimal transfer, then the Flask app interacts with Postgres and processes the data to return the most optimal transfer. We also have set up a Kubernetes cron job that runs another containerized application in regular intervals. The application checks if the expected points for each player has been determined for the coming game week. If not, the application reads a train model from Google Cloud Storage and then predicts the expected points, uh, calculates the expected points to enable communication between the cron job and and GCS. We've used workload identity. Um, so now I'll show you show you the demo. Sorry about that. Um, so if you click get best team, you'll get the whole team, like the most optimal team from the this I assume is from the cache. Now the user can enter whichever players there are in this team. So suppose we can give Mbuemo. Mm, so and let's keep the remaining budget at zero. So if we click this, yeah, we'll get the most optimal transfer would be transferring out MBMO for EVOB, which would give an improvement of 7 points. Mm, so I can also show you, as you can see, um, these are the pods running, these are the services running, and we also have uh, a cron job running. Um, so yeah, it is the cron job is not currently running because as I said, it's in regular intervals. So uh, once we get to the next point, it'll run again. So mm, this. Now let's go into debugging and testing. So we've mainly used Minikube to uh, deploy our services locally to test and debug them. Another method we used a lot when deploying our services in GKE was to maximize the use of Kubernetes cluster logs, which we use get using Kubernetes kube control logs pod name. For debugging the web app, we use Chrome DevTools for the front end and mostly Postman for the back end. For critical operations such as mm debugging database connections and Redis connections, we've used logging statements. And for testing our ML model, we've used R square score and means MSE, which stands for mean squared error, to determine the accuracy of our model. So now let's talk about the key takeaways from this project. We came to know how we can modularize parts of our application to make it easier to manage and scale. Modularizing also helped make the process of developing and debugging easier than it would usually be, where all the modules are interconnected. It helps us scale services easily, and if there are some performance intensive tasks, for example, in our case, the cron jobs, it won't affect the user experience. Um, Now let's talk about the limitations or bottlenecks. So the accuracy for our point predicting model could be improved from the already 83%, which would help us avoid some computational overhead. The autocomplete feature that I showed you during the demo requires constant calls to the backend. In case of high traffic, this would put a heavy reliance on the network performance between these services. Um, Another thing we could do is encrypt the models we have stored in machine learning models we have stored in Google Cloud Storage. Mm, so yeah, that's it from my side. Thank you for your time. Have a good day.